Okay. So, hi everyone. This is another webinar of our series on Kubernetes. Today we have Spiros talking about debugging Kubernetes services and nodes and some of the best practices that can be followed and the tooling available. He'll be talking for the next half an hour or a bit more. There will be questions at the end, but feel free to raise your hand or post a question as we go. And we can also, Spiros will reply during the presentation. That's it. So go ahead, Spiros.
Yep, thanks, Ricardo. So, hello. I'll talk to you about debugging usually broken nodes or services, and hopefully you don't have many. So, I'm a member of the CERN cloud team. I started identifying myself as a container firefighter with severe burns from fights. But I'm also a core member in Magnum project in OpenStack, and I contribute to Fedora and CentOS. So we will basically talk about three things today. What is in a worker node, and try to figure out if something doesn't work in our service or in our cluster, why it doesn't work, how to debug it, like how to debug the nodes and all these components that run inside them, and then how to migrate to new nodes or to be fresh and have smaller uptime, and or how to replace broken ones. So what is in a Kubernetes worker? So usually we're talking about Linux machines, although it's possible recently to have Windows machines as well. But yeah, the vast majority is Linux. You have the operating system. In our case, in the CERN cloud, and in most cases in the Magnum project, is Fedora Atomic in the past and Fedora CoreOS recently. And it has like the kernel from Fedora, which you can see here, for example, in one of the snippets. And then the stack builds on top of the kernel. The most base component is Docker and recently Containerd. And then we have the kubelet that is like the core component of the worker node for Kubernetes. And usually it comes together with kubeproxy, which has different modes. Of course, in a RHEL-like system, but also in Ubuntu and SUSE, you have systemd to manage the base services for the system. But when you use Kubernetes, you don't see that. And together, you have a CNI plugin, which is the Container Network Interface plugin, and some CSI plugins, which is the Container Storage Interface, to do automatic provisioning for CFS, for example, block storage with OpenStack Cinder, or CVMFS if you're at CERN. And then, of course, you have your apps. All these components usually consume very little memory, in the order of tens of megabytes for loaded nodes. So they're very minimal, and if they have high memory utilization or high CPU utilization, something is wrong. Here at the left, you can see that I have just a snippet, and to explain quickly what it shows, it's just the name of the node. It shows that it's up. In this case, it shouldn't be a master, it should be a worker or have none. But what is also important is that the OS image is like the operating system of the host, the kernel version, and the container runtime, which in this case is Docker, shipped from the Fedora repos. But in other cases, you might see Containerd and the semver of Containerd. So before jumping into the node, just look it from the outside to check when a node is up. Is it just this ready field, or there is more? Well, there is actually more, but the ready field of the node usually catches everything, and there are plugins that operators can implement to have custom indicators for the nodes that are ready. But by default, you get what I have in the bottom left, that the kernel is fine, the file system is okay. For networking in this cluster, we have Calico, and it runs fine in the node. And the node doesn't have pressure in memory, PIDs, and so on. And that which is not shown here, that the CRI, in our case, for this cluster Docker, for container runtime interface, is reporting back. So there is a control loop that the kubelet implements and checks all the time the state of the runtime and tries to implement it. So Kubernetes has this logic of the desired state of the world and the actual state of the world, and it always tries to match it. Usually this is done with countless control loops that the Kubernetes components implement. Now, specifically for clusters at CERN, and usually now you get by default Calico. And as you can see here, we have the Calico node that is running and two storage plugins. One is CSI SFFS and one CSI CDMFS. And at the bottom, I just realized that it's not trivial to report for kubectl, but if you curl the health set of the port, you can check even by hand if kubectl is replying. So now we'll go inside the node and we can check and we can see how does this look like. So this is my cluster that I took this information from, and we will SSH now in node 0. This is a Fedora CoreOS machine, so you SSH with core, and this is the host name. And we're in the node. So we have sudo access with this machine. And what we can check, it's Docker that it's running. So we have Docker version 1809 as it's reported by the kubelet. It has 30 running containers and a couple of them stopped that are deleted containers that are not cleaned up yet. What else do we have? We have the kubelet, which we can inspect with systemd that it's running. So as you can see here, it says active running, and this red and dangerous color that we see from systemd is that, as I will explain, kubelet runs inside the container as well, and before starting a new one, it tries to remove the old one, but that's not so relevant. But we have it there to make sure that even this expected failure is there. So aside from that, you can even check, of course, Docker with systemd. And the other important component that runs managed by systemd as well is kubectl, which is running again. And it doesn't have any errors. It has only info messages, which is indicated by this letter here, because it's the way Golang reports logs. So as I mentioned, these components in our clusters run as containers, and these are managed by systemd together with Podman. So we can do Podman PS, and we can see that we have here kubelet, kubectl, and a component from OpenStack that users do not interact with it. And since the pod implements the Docker API, you can even exec if you want inside the kubelet. But there is absolutely no way to do it. But in any case, I can show you that this is what I'm saying is actually true, and everything is managed by inside containers and shipped as container images. And you can see here that this image has all the Kubernetes components. What else you can do is you can even inspect that containers are running. You can do that with Docker PS, and you can see that we have many containers, 33, and I can to have some sanity, you can remove from the list the pause container, which I will explain what it is in a bit, and count again, and it's 21, and so on. But as I will say later in the presentation, and I will explain why you don't have to do all that. You don't have to log in ever in the node, because if you end up logging in, the deployment is wrong and it needs to be either drained and be replaced with newer nodes, and migrate the workload elsewhere and delete the broken nodes. Because even if you SSH in the node, there is not much you can do. If you change the state of the application, this will not match what is in the Kubernetes API. Kubernetes will try to fix it. If it's a broken plugin, it's as you can see here, it's again managed by Kubernetes. Your best bet is just to delete it, and Kubernetes will make sure to restart it and ensure that the state is correct again. Even for Calico, which is a very core component, all its state and knowledge is in the Kubernetes API. It uses custom resource definitions, and all the state is maintained by the API server and the controller manager of the master node. So why you don't have to SSH into the nodes? There are two ways that you can debug components and applications in these nodes. One is with the just newly added kubectl debug command that we'll describe after. And the most trivial, like the poor man's choice, is deploying a daemon set in and either deploy it in every node or just do it with a node selector and only specify particular nodes that you want it to run. A common practice is to run this daemon set with an image and then operate a system that you know about. For example, you might be very familiar with Debian or with CentOS. Or if you want to do very minimal tasks or you don't have a lot of bandwidth and you want to pull small images, you can even use Alpine. In my case, I have a debug image, which is based on a Debian Buster, which starts with 20 megabytes. And with all these utilities that is more for debugging processes and network, it goes to uncompressed around 150 megabytes. So it's a reasonable size if you have a registry in the data center. And then you can craft a daemon set. And if you want this to have like superpowers inside the node and be able to see whatever you need to check, you need to give it the host process ID namespace so that it can see all the processes. In many cases, you want it to have host network because if you try to debug something about networking, if you use host network, the pod will be scheduled in the node and it won't be blocked in case that the CNI plugin doesn't work. Calico or Funnel, they cannot give it an IP, or even if some kind of health check tries to hit this IP and it breaks. With host network, the kubelet doesn't care about this. It passes it the host IP, and that's it. And then if you want to touch different files in the file system, at least for Fedora CoreOS, you need to specify in the security context this as Linux label, where SPC stands for super privileged container. And then of course you can run as root or just use privileged true. Now, when you have this container running, you need to check if you do the process, you don't have to specify any mounts. You can just ignore the slide and just run with a sleep command this container. Or the ideal one is you can mount / from the node here and mount it in host FFS, and I will hostfs, and I will show you how does this look like. Or if you want to do more advanced stuff, and but beware that this is dangerous to harm the node, you can mount specific hosts, host paths inside the container, like etc, var, and run, and then you can have access to the dbus of the node. You can talk to systemd. It's almost like being in the host, and even have more packages and more applications and the capability to install more things inside. So let's go and look how does this look like. So I was inside the node. I logged out again, and here we can check my debug manifest. And if we go to volumes, here, as I showed you, I had mount / in hostfs, and I have a config map, which is a convenient way to pass a script, and I share to you as well for convenience. And here as well, I have the image that I described before, but this could be the operating system or the image that you're familiar with, or even your own handcrafted image, because if you develop something in C, you might want GDB inside. If you develop in Python and you want to debug a Python application, maybe you want to have some Python tools inside. And of course, I have to have the volume mounts. So here I say that hostfs must be mounted in /hostfs. And for completion, I will also show you that here is the script that I specify. So this is also a convenient way to run something inside the node or in a loop, and then have it printed in std out if you want to do this kind of debugging. So now we'll apply this manifest. It's already deployed from a previous run, and you see there are no changes. So now if I go and check a node, I can do this runs in kube system, and I can get the pods, and I can get also the nodes, and I will grep for the name of the pod that I have. So these are the pods that run in all nodes. And for example, I want to debug node 2. So I want to exec in this pod. So we'll just use again kube system. And this is Debian, if you remember, and it has bash inside. So now I am inside the container. And you can see here that the container, because it runs with host network, it gets the host name of the host that it's running. And here I have many convenient commands like hstop that has colors and it's pretty, and it shows all the processes that are running inside. I can verify even with PS to check how many processes I have. I have 173 processes, and I have more useful tools like strace that I will show you how it works later after I'm showing kubectl debug. So now, if you remember, we mounted in hostfs the host file system, and you can see here that I can see all directories. So this is very powerful. You can see all the mounts and even the proc file system of the host. And well, you don't need it because you run in the host PID namespace. But you can see even mounts the state of kubelet and the state of Docker. For example, the kubelet stores all its state in valid kubelet. And I can see here that I have everything inside, and I even wrote something before. And if we go even further, we can even see different plugins that we have. Here I have 2 plugins that are running already. And the same whole stands for Docker. I can see all info here. And here, in fact, are all the containers that are running in my machine. I can pick one, and I can do even low-level debugging. I can see its logs. I can see the full manifest that Docker inspect returns, and so on. Now, as you saw, this is very intrusive in a way in the node because you can see everything, and you may want to limit what you can see, and to save yourself from shooting other applications or even touching systemd and do harm in your nodes. By the way, all the manifests, you can find them in GitLab. Here, it's a public repo. You can clone and you can do whatever you want. And of course, I will link everything in the Indigo page of the event later. But in many providers and in many deployments, people were doing this, and probably like me, that I did very frequently, I got sick of it. And there's a new, more advanced way, and I would say almost perfect. There is only one missing part that it misses, and that I have linked here, which is kubectl debug. This is actually kubectl alpha debug because it's not stable yet, and it needs extra configuration to be enabled. This is the first link is the documentation. You can read all about it and follow a tutorial, but this is like the gist of the tutorial, and I will do an example with it. This was added in this release as 1.18, and as I mentioned, you need to define a specific feature gate, which is a way of Kubernetes to add new features in the project. And in the Magnum project, we have specific labels that allow this. I have not included it in this presentation, in this slide, because I couldn't find an easy way to fit it, but in the updated slides in Indigo, I will add it as well. But for completion, I will show it to you in my speaker notes that I have it to make sure that you know what I'm talking about as well. So as you can see here in the speaker notes, I'm not sure if I can increase this. Yes, you need to pass the ephemeral containers through as it's indicated in the documentation. And if you specify all these commands that I will include in the slides, you will be able to use this feature that I will now demonstrate. So let's go back to the presentation. So what this does, if you're familiar with Kubernetes deployments, you have one or more containers per pod, and then you can have some init containers that are executed before the main application, and you can have many. And then the init containers go away, and you have only the main containers. If you restart the pod, if you delete it, Kubernetes will start again the init containers and then the normal containers as well. Ephemeral containers is one more entry that you don't control at the moment with manifests, but you just interact with it with kubectl alpha debug. And what this does is that it adds one more entry like init containers, which are called ephemeral containers, and it starts with a specific command inside. But the peculiarity of this is that when you delete a pod and then it starts again, this container is gone, is not started again. In this example, one of the components that from time to time cause trouble is DNS. You may know the famous haiku that I cannot believe it's DNS again, but this particular container, as it's shipped by the core DNS developers, it is a from scratch container that has no shell, and you cannot basically attach to it and inspect it. What we will do here is, in my initial demo that I have it, I used CentOS, but in our case, we will use this Debian with a lot of packages inside. And we will target the core DNS container that runs inside the deployment. And here we will pass a sleep command. So what this will do is it will inject an extra process that sleeps, and we can exec inside it. Then we will be able to inspect it and see that is indeed in the spec of the pod, and then we can execute it. So let's see how that works. So let's say that in one of these two containers, I want to see how many requests they're receiving. So if I attempt to exec inside, Let's pick this one. Kubernetes will say that bash was not found in path. Let's try to be sneaky and use shell, because if it's Alpine, it might be shell. But as you can see, there is nothing. What I can do is I can execute core DNS again, but this will cause more harm. So what I can do instead of that is use this command to do kubectl alpha debug. With image, I pass my debug image. I target the container I want. In my case, is core DNS, and the pod I want, which is the previous pod. It's this pod. And this container will start with a sleep command for 1000 days, which is extremely optimistic. The command, of course, is namespace. So this says now that a container with this name started. I can even specify a name if I want, but this is randomly generated by Kubernetes. So what I can do now is, if I describe this pod, I see that a different error message. Was it another one? No, it's this one. Let's do get pod. And if we go to ephemeral, you see that there's an entry with ephemeral containers. This is the name, and this is the image that I specified from Ariba. So now we'll be able to exec into that one. So this is the previous command with exec that didn't work. But this time I will say that I want to exec in this container and not in the default container of the pod, and launch bash. So now I'm inside, and I can see which processes are running in this pod. And as you know, in containers, when Docker starts a container, it starts with PID1. So core DNS, the main process, starts with PID1. And this is my command that I am inside for the sleep. This is the shell that I exec, and the PS that I just ran. So what I can do now is, I don't have TCP dump. I thought I have added it. So see, here I can even install packages. At CERN we have great speed, as you can see. You can even use it. So now I will do TCP dump, and DNS is using UDP. And now I'm capturing all the traffic that goes into core DNS. And if we are waiting, we can even see services that are running here. This is the CERN DNS that is reaching to, and if one of the components tries to resolve something here, we will catch it as in the output of TCP dump. Yep. See here that one of the containers in processing the node in the cluster actually requested what is the IP of hipster, and coordinates replied. I have all the documentation here. You can follow this, and now we will move to what more you can do. I already showed you PS stop and so on, but there might be cases that you want to trace applications, and the usual one is do lookups and so on. And for other applications that are compiled in debug mode, you can even use GDB. So now let's run one of these applications now. The application that I'm going to run I have the container built here. I think it's example. Yeah, it's a dummy Golang application that writes to a file, and this is again a from scratch container that is 1.5 megabytes only. And obviously, this is very difficult to debug if you don't have any tools or shell to work with. So I will go to the project and I will apply my manifest. So this is just being created, and at the same time, it will create even a share in SFFS. And we can see that we have a pod that it's waiting for the PVC, and the PVC that was created like 15 seconds ago, and it's bound, and our pod must be running now by now. Okay, let's try to do the same. Try to exec. Kubernetes will say that I wasn't able to do this. It says again that there is no shell. Of course, 1.4 megabytes. It's just the size of the kernel and the small app. So what we can do now is we can use debug again. So this time I will run in the default namespace with the same image. I will target this name, which I know it's my container's name, in this pod, and it will sleep again. So now, as we did with core DNS, instead of execing in the main process, I can exec in the debug container. And there we go, we are inside. In this case, it doesn't have a host name because I don't run any with any privileges inside this pod, and I can see all the programs that run inside. I named my application program, and now we can even do things like a trace for PID1, and this will capture all the actions that this process is doing. And you can see here that, as I told you, what this application is doing, it writes in a file in SFFS, which is in /tmp, and we just got this with a TCP dump because it tried to open a file to append. So I will just demonstrate to you that this is what it's doing. If we check in the code of this application, you can see here that I open a file called tmp.1. And if we go in the manifest, you can see that I mount my PVC in /tmp, and I can continue debugging like this. A limitation that I found here is, apart from that you have to enable on cluster creation or then modify all the nodes, is that kubectl debug doesn't show all the mounts. So in this container, I have mounted /tmp. But what we can do instead of that is we can go to the other debug container that we have already in place, and we can inspect the files that we have there. So if I list, so what I'm doing now is I'm getting the pods in all namespaces. I'm creating the node name as well, and I'm grabbing for the specific node that my example application is running. And then I can grab for my daemon set that it's cloud infrastructure debug. And we found it. You see we have only one entry. So if we do again exec in this pod, I can even show you where the share is mounted in the operating system. So if you remember, we are in hostfs, and kubelet that mounts shares and other volumes is in varlib kubelet in plugins. And if I go to Kubernetes, I can see that I have CSI PVs, and I have a PV here. And because this is a SFFS mount, it has global mount, and you can see that one file that my process is running, and I can even cut it and count the lines. That I write hello every second. And to prove that to you, I can show you the contents that is just hello, that writes every second. So this is for debugging. Now that you might find something, you may be able to fix it by restarting the pod, or if it's an error in the application, you can redeploy. And if it's something broken in the node, your best chance, if you're using Kubernetes and cloud and the patterns of deploying with Kubernetes, what you can do is just replace the node. So what you can do is replace broken nodes. I will come back to why I use node.ssh because I have more arguments there. So if you identify that node is broken, it's not the application's fault. Or if a plugin is not working, you cannot mount Ceph, or you cannot mount CMFS, or the network is misbehaving. You can just use node groups or just OpenStack API to add and remove broken nodes. So in this case, you can see that I assume that node 5 is broken. What I can do is start by cordoning the node, and then I can add a node by increasing the count to 6. It will add more nodes. And if the problems come because my flavor was too small, I can create a new node group and I can specify a different flavor, or even I can append labels and select a specific availability zone that we have in the cloud. And then you will drain the misbehaving nodes because you will have more capacity. Then you can drop node 5 again, which is the problematic one, and you can follow it here, that it's node 5. Here we drain it and here we remove it. And just know that for ingress, you must relay, if it's an ingress node, you must not forget that at CERN, you must use the label to specify your DNS alias, or with LandDB sync, this is done automatically. And finally, in many of our users use service type load balancer, and they can they don't have to do all the relabeling nightmare, I would say. So before closing, what I can show you, what I can tell you is why you should not SSH. For me, the first reason is that it's tedious to go inside the node, that it's optimized just to run containers, and it's almost impossible to install new packages. If it's a user's node or if it's a shared cluster, we don't want to pollute the cluster with SSH keys, although it's possible to do cleanups after, but there is no reason to do this. And also it's better to use the same patterns that you have to deploy applications with the same patterns you can do debugging. Instead of carrying scripts and leave them inside the nodes, you can use declarative deployments with Kubernetes again. And of course, sometimes you might not have access. Furthermore, we are improving the way that users authenticate with the clusters. Right now is with their certificates, but we have also Keystone as a way of OpenStack Keystone as a way of getting authorization from the API server, and soon we will add also the new IDC of CERN. And with this pattern, it's very easy to grant access and also remove access by adding a group at CERN, or a person to a group, or in a project in OpenStack. And yeah, I have also one more comment that instead of putting binaries or scripts or SSH keys, you just add images in the cluster, and kubelet will garbage collect all these images eventually. I think these were all my slides. Yes. So thank you. And if you have any questions, you can raise your hand. Thank you. Ricardo?
Cool. Thanks, Bruce. This is awesome. I don't know if anyone already has some question to ask. Yep, there's Diego. Go ahead, Diego. You can unmute.
Hello, can you hear myself?
Yes.
Okay.
Go ahead.
So I have this worry that for the advanced way of debugging, that you would get all the privileges in going in, you have to get all these complex manifests. So this won't be available through this alpha debug, if that's correct, right?
If you use alpha debug, yes, you just used kubectl and it attaches a container cleanly, and then you exec only there. You don't have to maintain any manifests anywhere.
Exactly, but if you want more privileges, because let's say there is something that you would have to check further, like that wouldn't fulfill the use case.
Yeah, you need to have it's a very simple daemon set that mounts the host file system to
Okay.
expect further.
So my question would be, would that be something that you will share in your docs and maintain? Something that we would have to maintain? I guess this is not going to happen every day, but just when it happens, you really want to have it quickly, right? It's just that.
These specific ones are shared already, so you can use them at will, and there is no will to bring them down. But having something permanent in the docs, I don't know, maybe Ricardo can answer that.
Well, for sure, the container you were showing for debugging with all the TCP and tracing tools, I was just taking a note and opening a ticket. We've been using this, but yeah, we don't have it in the documentation yet. I think we should have it. I guess this is very useful.
Yeah.
I would ask Diego just for the one with the SSH. Is that the one you meant, or you meant the debugging one?
The debugging, yeah.
Yeah, that one. Yeah, we will definitely add it.
Great, thank you.
And since it's very static, we won't change names or URLs. I guess frequently it will be static forever. You will be able to use it and make sure that it's up to date.
I guess we can keep a stable tag and just add tools as people request
Yeah.
them. Any other question? Feel free to raise the hand. I have one for the also debugging. In terms of privileges, I think it was also related to what Diego was saying. You were showing, so this is a new container in the same pod.
Yeah.
Is there any restriction on what this container can actually do in practice?
No, there is no restriction. In my example, I specified -- target, which means that it attaches to the container that you target in the PID namespace. And in general, it inherits from the pod all the configuration. The only part the only restriction I found, but maybe I'm missing something, is the mounts, because I think the standard containers have their own mounts and the ephemeral do not inherit those mounts. Like in init containers, you have different mounts, volume mounts, instead of the normal containers. Other than that, it's if we try to simplify, like having a machine that runs this application and you have access only as the user that is supposed to use that machine.
Okay, so it can get basically all the privileges of the pod apart from mounts.
Yeah.
And it can get more than the pod?
For now, no. It's possible, I think, if you use directly the API and send YAML or JSON payloads, but with the kubectl command, it's not there yet. There is work to add more privileges, and there is also work to allow deletion, because this container now will stay forever there. Forever, as long as the other containers are running.
Cool, very good. Any other question? Comment? Okay, I think this is it then. Thank you very much, and yeah, thanks, Spiros, and thanks everyone
Thank
for
you.
attending.